Hey guys, this is Mr. Grice for Algebra 1, Unit 6.1 Notes. Today we're going to be talking about properties of exponents. Our learning target today is to be able to apply the properties of exponents in order to simplify exponential expressions. So let's take a look at our example, 3x to the fourth. There are four things that we need to know about this example right now. What the coefficient is, what the base is, what the exponent is, and what the power is. Now, as you can see, I've already filled some of that stuff out for you. The coefficient is the number in front. It's a number multiplied by a variable. Okay? So the 3 is being multiplied by the x. And in this scenario, the 4 does not apply to that. That exponent doesn't apply to it. Okay? The base is any number or variable that has an exponent. Okay? And I'm going to bring up another note real quick, so don't be freaked out. These two things, 3x to the fourth and 3x to the fourth, are completely different. Okay? There is a difference between these two guys. Okay? Now, what is the difference? Well, the base. The base is directly next to the exponent, where this one, the first one, the exponent belongs to the x. Over here, the exponent belongs to the 3 and the x. Okay, and those parentheses make a huge, huge difference. Okay? Now the exponent, which is the 4, tells how many times to multiply the base by itself. And then the power, well, the power is the base and the exponent together. Okay? How are we doing so far? If you need another minute or two to write that down, pause the video. Otherwise, we are moving on. Now, today we're just going to cover these first 3 rules. Tomorrow we're going to talk about the bottom 2 rules, okay? All right, let's get started. Okay, so the first rule, we're talking about the product of a power. And in the word product, the product means to multiply, okay? So if you see 2 or more of the same base and they're multiplied, what we're going to do is we are going to add the exponents. You're like, why are we adding? You just said to multiply. No, I said if there's multiplication, okay? So, and one thing we need to know real quick is we have to make sure to keep the base the same. So let's zoom in and take a better look at this example. Now, if we were to write 2 to the third out the long way, well, first let's see how they have the same base. So now let's just talk about 2 to the third. 2 to the third means 2 times 2 times 2. There's our big multiplication sign right there. And what about that second one? Well, that second one means 2 times 2. Well, how many 2's do we have altogether? 5. So we would say that that is 2 to the 5th. The shortcut to that would be saying, well, I'm going to add my exponents. 3 plus 2. Well, 3 plus 2 is 5. Ta-da! We got the same answer. Okay? But now, anytime we have a number with an exponent, we always want to find out what it is. We always want to simplify our answer all the way. Okay? So, on your calculators, I would write 2 to the 5th power. Now, you might not be able to see it, but that little caret right there, that's the one that means exponent. Okay? And so we get our answer of 32. The reason we have that shortcut is because for our next example, x to the 15th times x to the 7, you don't want to sit there and write 15x's out and then write 7x's out, when all we can do is, I notice they have the same base, the base stays the same, we do 15 plus 7, and we get 22. Okay, so that's the product of powers rule. Now our next one is the quotient rule, the quotient of powers. And quotient means to divide. Once again, you always want to make sure we're talking about the same bases. And when we have this, we want to subtract. And we're going to subtract the exponents, but we're always going to keep the base the same. We never change the bases. Okay? Now, I'd be like, Mr. Grice, why do we do that? Let's do this the long way. Okay? Once again, 3 to the 5th, if I were to write that out, it would be 1, 2, 3, 4, 5. Okay, on the bottom, we have 1, 2, 3, 4. What we can do is we can cross off pairs, and they cancel each other out. And we're left with 1. And is that 1 on the top or on the bottom? It's on the top. Okay, so pretty much what we did, 5 minus 4. Well, 5 minus 4 is 1. Now, if your exponent's just 1, you don't have to keep that 1 there. You can just leave it the way it is. Now, the bottom canceled out. And so when we cancel out with division, we have a 1 there. Now, the last thing we have to do is we can simplify that. 3 divided by 1, we don't have to keep it like that. We can just say that, hey, our answer is 3. Okay, so the way we're doing this is, look at our next example. We're not going to write down all those m's. I want to know, are there more on the top or are there more on the bottom? Who wins, the top or the bottom? Well, the bottom wins. Okay, so I know that my answer is going to be on the bottom, and I want to do 20 minus 17. Well, 20 minus 17 is 3. But we don't write our answer like that. There's got to be something on the top. Okay, anytime it cancels out in division, it cancels out with a 1. So we're left with 1 over m to the 3rd power. Okay, so now we're talking about the power of a power. And what the power of the power says, if a power is being raised to another power, what we're going to do is we're going to multiply the exponents. Whoa, what happened? We don't need to do that yet. Okay, and remember, we keep the base the same. We are not changing our bases. So what this is saying is, we've got that exponent out there. That tells me how many of the base we have. And this is where we got into the point right here, where this whole part is my base. That exponent belongs to both of those. Okay, so what that means is I can multiply that, but I can only multiply it to something that has an exponent. Excuse me, sorry, I just sneezed. But you can only multiply it to something that has an exponent. Well, Mr. Grice, that 4 doesn't have an exponent, so I don't have to multiply it to it. Yes, you do. We just talked about it in our last example, that if there's no exponent there, it always has an exponent of 1. Okay? So I need to multiply everything that has an exponent. Okay? So 4 and W. I need to know what are my new exponents. Well, 1 times 2 is 2. And 3 times 2, well, 3 times 2 is 6. Well, am I done? No, no, you're not. Because you can simplify 4 squared. Okay, 4 squared is not 4 times 2, it's 4 times 4. And 4 times 4 is 16w to the 6th. Okay? All right, and let's do the next example. Now, I want to make sure, even with division, that 2, the exponent, belongs to everything. So I'm going to make sure that I put an exponent on the 4. And now we're going to distribute that. Okay? So I have a y, and then I have a 4. 3 times 2 is 6, and 1 times 2 is 2. Okay? We can simplify that. I can't simplify the top. Y to the 6th is just y to the 6th. I don't know what y is, so I can't change anything. Okay, and then 4 squared we just did is 16. So we get y to the 6th over 16. Okay, those were the notes that we covered in class. We're going to cover these two properties tomorrow. I'm going to stop the video, but the rest of the video in class is we did 6.1 in class practice together. So 6.1 in class practice is going to be its whole own video, so if you need to watch that, go ahead and look it up. Okay? But this is Mr. Grice signing off for Algebra 1, Unit 6.1 Notes. Thanks for watching.